Have you ever clicked on something and just stopped for a second to wonder, what is actually happening inside that metal box? I mean, how does it go from a simple click to a whole world of information in literally the blink of an eye?
Well, it definitely feels like magic, right? But today, we're going to pull back the curtain. We're going to break down exactly how your computer thinks, how it remembers, and how it communicates, and turn all that complexity into something that actually makes sense.
So here's our game plan. We're going to take a journey, starting with the absolute core of the machine and building our way up. We'll cover the computer's brain, then its memory, its senses, and finally, we'll see what happens when it all works together. Let's start with the heart of it all. All right, our first stop is the absolute engine of everything, the central processing unit, or CPU for short. Literally nothing happens without this thing.
You should really just think of the CPU as the computer's brain. It's the conductor of the entire orchestra. It takes in every single request you make and then directs all the other parts of the computer to get the job done. But how on earth does it handle billions of tasks every second?
Well, at its core, the CPU runs on a really simple but incredibly fast three-step loop. First, it fetches an instruction from memory. Think of it like grabbing the next item on a to-do list. Then, it decodes that instruction to figure out what it's supposed to do. And finally, it executes the command. And this simple cycle, fetch, decode, execute, repeats billions of times every single second. It's kind of wild.
And this analogy really helps make it click. Imagine a chef in a busy kitchen. The chef fetches the recipe, right? Then they decode the instructions, chop the onions. And then they execute that step by actually chopping them. The CPU does the exact same thing, just with data instead of food.
Of course, a brain, or a chef for that matter, is pretty useless without a place to store information. And that brings us to our next crucial component, the computer's memory.
Your computer really has two main types of memory. There's primary storage, like RAM, which is its super fast temporary workspace for whatever you're doing right now. Then there's secondary storage, like your hard drive or SSD, which is the permanent file cabinet where everything gets saved for the long term.
Here's a perfect way to picture it. Your desk is your RAM. It holds the books and papers you're actively working on. It's fast, it's right there, it's easy to access. Your locker? Well, that's your hard drive. It stores all your books permanently, but you have to actually go get them and bring them back to your desk to use them. So a bigger desk, more RAM, means you can work on more things at once without slowing down.
Now, it's really important to know that not all memory is the same. RAM is your active, working memory, but it's volatile, which is a fancy way of saying it forgets everything as soon as you turn the power off. That's why you have to save your work. ROM, on the other hand, is non-volatile. It holds the permanent, unchangeable instructions the computer needs just to start up. You can think of it like the computer's basic instinct.
So this little table gives us a quick summary. RAM is for your active work, ROM is for getting things started, and storage is for keeping your files forever. Each one plays a different role, balancing speed, purpose, and whether or not it forgets things.
Okay, so we've got a brain and we have memory. But how does the computer actually interact with us? How do we talk to it? Well, that's where its senses come into play, the input and output devices.
Input devices are pretty straightforward. They are anything we use to send information into the computer. Your keyboard, your mouse, your microphone, they're all just different ways for you to give commands and data directly to the CPU.
And yep, you guessed it, output devices are how the computer communicates the results back to you. The monitors show you images, the speakers give you sound, the printer gives you a physical copy. It's a two-way conversation.
So, we've built our computer. We have a brain to think, memory to remember, and senses to interact. Now here comes the amazing part. What happens when you feed a massive amount of information through those senses and then have the brain process it all at lightning speed? You start to get something that, well, it looks a lot like intelligence.
So, what is the modern peak of all this fetching, decoding, and executing? Let's look at a perfect and very popular example, ChatGPT.
The key thing to understand about ChatGPT is that it doesn't think like a human does. At its very core, it's an incredibly sophisticated pattern-matching machine. It's been trained on a colossal amount of text from the internet, and its main job is just to predict the most probable next word in any given sequence.
For instance, by analyzing countless sentences, it's learned that after the phrase, "the Earth revolves around the," the most statistically likely word to pop up next is sun. It applies this exact same logic to everything, just on a massively complex scale.
Think of it this way. ChatGPT is like a super librarian who has read every single book in the world. When you ask it a question, it doesn't go look up the answer in one of those books. Instead, it synthesizes a totally new answer based on all the patterns and connections it remembers from everything it's ever read.
And this right here is how it all comes together. When you use ChatGPT, you engage every single component we've just talked about. You provide the input with your keyboard. The CPU and RAM process the data, predicting the next word, then the next, over and over again. And finally, the result is sent to the output, your monitor. It's the entire system working in perfect harmony.
So, after all that, we're left with a pretty fascinating question, aren't we? If a machine can perform these incredibly complex tasks just by following that simple fetch, decode, execute cycle billions and billions of times a second, where is the line between calculation and consciousness? What does it truly mean to think?